Friends, welcome again into yet another session of mathematics into my YouTube channel, Maths with Mukesh Raj. And today we are going to continue with the coordinate geometry, and the points of discussion is going to be the centroid of a triangle and the area of the triangle, and henceforth the application of the area of the triangle that is supposed to be found out by the help of the coordinate system and the coordinates that are given to us. Before starting the topic, I would like to appeal to all my young friends that please do not forget to like, share, and subscribe my channel, and share it with your family and friends as much as possible, because that share, like, and comment really motivates me to come up with new and interesting videos for you, so that this mathematics is made a fun for you, and by this you may score better into your exams. So let us directly switch on to the topic, and the centroid of the triangle. If we talk about the centroid of a triangle, the centroid is defined as the point of intersection of the medians of the given triangle. In a very short discussion, let us understand what exactly median means, or we should just take a quick review of the medians, the meaning of the medians. Medians are the lines that are drawn from the vertex of any triangle that divides the opposite side of the triangle into equal halves, and such a line is treated as the median. Now this median can be formed of in the ordered pair of g of x. Let's suppose that we need to find out the median of any given triangle with required points. Then for this it will be an ordered pair, and this ordered pair will help us to reach to the centroid of the triangle by taking the sum of each of the values of x, dividing it by 3, similarly taking each of the values, sum of each of the values of the y, and dividing it by 3. So this is how the median, or we can call it as the centroid of a triangle, can be found out. Now this centroid of a triangle can also be differentially calculated by the help of this value as g of x and separately g of y. These two separately gives us the centroid value for the coordinate x and y respectively, and this will lead to finally the calculation, or finally we will get the value as g of x and y. So this particular point that we have calculated in the form of an ordered pair, that is g of xy, is the actual centroid of the given triangle. Moving ahead, friends, let us talk about what exactly is meant by the area of the triangle. Okay, let us first understand this centroid by the help of an example, that how we can find out the centroid of a given triangle. The centroid of a given triangle can be found out by, let's say that this is the given triangle. Okay, so this is the triangle for which we need to find out the centroid. For the given triangle, 3 different points: -3, 5, -2, -8, and 5. So these are the basic different 3 different points for which we need to find out the centroid. Let's not waste time and see how can we reach up to this solution. First, we have to get them bifurcated, or we have to note it down by the help of this formula, which is being written in this way. And what we will do, we have to first differentiate each of the given point with respect to x1 y1, x2 y2, and x3 y3, so that the simplification of this particular problem becomes easy for us. And after that, we will very minutely and very cautiously, we have to put the values into the given formula as for the given equation formula that we have already seen: 1 upon 3 x1 plus x2 plus x3, or 1 upon 3 y1 plus y2 plus y3. This is the formula that is going to give us the centroid. So keeping this putting this formula very cautiously, we will reach to the first value, that is x. Centroid value for x is going to be -2, and centroid value for the y is going to be +1. And then we can finally write it down as g of xy, as we have already discussed, will be equal to, and can be get in the ordered pair of value -2 and 1. So this gives us the centroid of the given triangle with 3 different vertices a, b and c. Now, the area of the triangle. The area of the triangle, which is again a very interesting topic into the calculation or into the application of the coordinate geometry, where the triangle with 3 different vertices, let's suppose we have been given with a, b and c, and this will help us to find out the triangle area by the formula. So this is the formula for the calculation of the area of the triangle, where we are taking the vertices a, b, c respectively as x1, y1, x2, y2 and x3, y3. Now the area of the triangle ABC the area of the triangle ABC will be 1/2 times the product of x1 and difference of y2 minus y3 added with the value x2 multiplied by the difference of y3 and y1 added with the value of the product of x3 and y1 minus y2. So this will give us the area of the triangle. Now interestingly, this what is the application? This is how we can find out the area of the triangle. But interestingly, this area of the triangle can be used to find collinearity. Okay, collinearity. Okay, this will help us to find out the collinearity of minimum 3 points. Okay, minimum 3 points. Now how is it that we can apply the area of a given triangle to get the collinearity of the given 3 points? It has got an implementation with respect to this. See, the collinearity of a given point is associated with the area of the triangle. If the area of the triangle equals to 0, if we are finding out the area of the triangle and if that area is equated to a 0, then we can say that all these 3 points are collinear to each other. Or else if we get a value less than 0 or any value except 0, will definitely not let all these 3 points to be collinear in nature. Now The formula implementation is very easy to understand, because it's just a certain calculative things that we should be known of. If we are aware of these basic things, we would be able to calculate this. First, we will take the area of the triangle as usual. The formula that we have already discussed, the area of the triangle is 1/2 times the product of x1 and y2 minus y3 with the added value of product of x2 and y3 minus y1, added value of x3 and the subtracted value of y1 and y2. Now what we do here is, if this area, this particular value of the given points is equated to 0, and then finally just we will be cross multiplying this 2 in the denominator with 0, that will give us a 0 finally, and hence we will get a value that is marked in blue colored, that is x1 multiplied by y2 minus y3 plus x2 multiplied by y3 minus y1 plus x3 multiplied by y1 minus y2. So finally, if we are able to get this equation on the left hand side equated to a value that is 0 on the right hand side, then only we can say that the points that we are discussing about will be a collinear to each other, all these 3 points. Now this can make us understand in a proper way with an example. Let us see the example. An example where 3 points, namely as A, B and C are given to us. Namely A, B and C are given to us, and our objective is to find the collinearity of the given points. That means these points A, B and C, whether they are collinear or not. So this collinearity can be found out by the process. First, starting from the formula, we will just try and get this formula equated to this way. Okay, starting from this, we will find the value for the last equation that we discussed just now, that is x1 multiplied by y2 minus y3 plus x2 multiplied by y3 minus y1, and finally it will be added to the value of x3 multiplied by y2 minus y1 minus y2, and we will equate it to 0. So taking into consideration, I'm just using the LHS term. First we will take the LHS term, where we will be using this value. The same value will be used. Now what we will do, we will equate, and since we have got the 3 points over here, we are going to use these values very cautiously over here, and then we will be equating them to a value that will be equal to a 0. That means it will finally lead us to this particular equation, that is 48 minus 48. That is equivalent to a value that is equal to 0, and this 0, as we can see, that it belongs to the right hand side. So here we have reached to our objective, that is 0 equated to a value, and that is our right hand side. So here finally we can conclude that these points, these 3 points A, B and C, and C are collinear. That's it. So that is all in today's session. Hope you would have understood and enjoyed this session. At last, before ending this session, I would like to thank all my young friends for watching this video patiently, and please do not forget to share it with your friends, family and the students who really need help with maths. So thank you very much, and have a great career ahead. May God bless you with good marks into your board exams. Thank you very much, friends.